Section 2.6, Part 4 video. They want us to look at the domain and range on this particular interval in written as inequality. So the domain would be 4. It's not including it because it doesn't have an equal, all the way up to 9 with a bracket. So what we're going to do is we're just going to graph this 1 over 4 minus x from 4 to 9. And so here we go. Make this go away. Clear. 1 divided by, open up parentheses, 4 minus x, close parentheses. So what you want to do is you want to make sure that you encapsulate the denominator. So by doing a parentheses down there, you'll be able to see that 4 minus x is all in the denominator, as opposed to 1/4 minus x. Okay, that's could be a mistake for you. All right, so we're looking at from 4 to 9, but not including 9. So let's go window 4, 9. That's the only thing I'm changing. And I'm just going to hit graph. All right, so it appears the lowest point is going to be at 4, and the highest point is going to be at 9. So that makes life a lot easier. We'll just look right here on our table. We'll go. All right. Well, it doesn't exist at 4. So the 9 is negative 0.2. So we know what the upper limit is going to be. Let me go back over. Negative 0.2. So with the bracket, comma, the range from 4 up is going to look like this. So let's see if we can just find something real quick. Let's go second table. Go ask. Go over here and just do 4.001. Let's say it's negative 1,000. Let's see what 4.1 is. Negative 10. 4.0000001. All right. Well, let's look at this. I'm making this harder than what it is. If it doesn't exist here, and that means this goes all the way down to negative infinity. So that just took care of it. It should be negative infinity, comma, negative 0.2. I mean, if it's going down and it never approaches 4, because 4 would make it undefined here. Okay, 4 minus 4 is 0, and 1 over 0 is undefined. So that would have to be negative infinity. There you go. All right, so similar tree grows at a constant rate. When the tree was planted, it was 3.7 feet tall, and after 5 years, the tree grew to 5.7 feet tall. Okay, so what they've given you is basically two ordered pairs. Okay, so use the function to model the tree's height as years go by. Assume that the tree can live 200 years. Find its domain and range. Well, it's not that bad. We can what we'll do is we'll just do a linear regression off this real quick. So kill this. Second plus 4, enter. Then go stat, edit, 0 and 5. And then, what is our points over here? 3.7 and 5.7. Enter 5.7. Enter stat calc number 4. And we're going to store it because we're going to do something on it. It's pretty cool. Vars, arrow, enter. Okay. All right, so there. 0.4 and 3.7. So 0.4x plus 3.7 is what it is. Now, just so I can clear up some things, we've had just looking at tests from chapter 1, chapter 2. Slope would be 0.4, not 0.4x. X is a variable, okay? If you're looking at this, this is y equals mx plus b, and m is the slope, so that would be 0.4. There, retaught that. So let's don't put x with slope anymore. Okay. All right. So 200 years, so 0.4 times 200 plus 3.7. You can find that that's going to be 83.7. 83.7. Okay, so from 0 to 200, I'm going to put a bracket. They may want to parentheses. They get traditionally when we talk about brackets and parentheses and stuff, this textbook that we're using is backwards. I don't quite understand why they're going against it, but I'm just going to say, trying to guess that they're going in brackets. So, and then the range, it was 3.7 tall all the way up to 83.7. And the reason why I put it on a calculator was this. Second table, let me clear this out. 0, enter, 200, enter. There you go. There's your domain in the X and range on the Y, because if I hit graph, you can see that it's a linear, it's increasing, right? So that gives me back this. So there. This concludes 2.6 part 4's video.